Today we will discuss asymptotic notations which are used in data structures. First let me give asymptotic notation definition. First of all, asymptotic notation is an used mathematical tools. Asymptotic notation used in mathematical tools. Notation used as mathematical tools, which is used in computer science, which is used to give an efficient algorithm, used in computer science, and which will give an efficient algorithm, gives efficient algorithm. So here we have four, not as per the syllabus university, 5 different asymptotic notations we have. The first one is big O notation. Big O notation. Second one is omega notation. Which is used with a symbol called omega. Here I am giving you symbol, that is omega. Third one is theta notation. So this is called theta. Fourth one is little o notation. And the fifth one is little omega notation. Little omega notation we will represent with W. Little omega notation. The symbol is like this here, W. Little o is it's a small o. Now I am going to explain a detailed description about big O notation. Big O notation, which is a most commonly used notation. And in big O notation, we have to use worst case time complexity. So here I already said that worst case time complexity means which gives more efficient result, means best time complexity result will give. How is it possible? Let me explain. So when you are doing with worst case time complexity, you already covered with the values of best case time complexity and average case time complexity. When you are doing with here, let me give one example. So let me write one example here. 9, 8, 7, 3, 2. So here worst case time complexity I am going to show you. Before going to worst case time complexity, let me give one best case time complexity. Suppose I want find value is 8. What is the find value? 8. The compiler starts its journey. So compiler is moving to the first one. It's not matching. And it is moving to the second block. It's matching. So it gives the best case time complexity, so that my value is finding in second block. So this is a best case time complexity. When I enter into the average case time complexity means, let me give one example. Here my finding value is 7. What is my finding value? 7. So compiler again starts its journey. It's starting its journey and searching in first block. It's not matching. The value 7 is not matching in first block, and compiler is moving towards second block. It's not matching in second block, and compiler moves towards third block. So compiler is enter into third block. Here the value is matching, so that it gives an exact result, that is average case time complexity. This is an average case time complexity. From this example you will get an idea. When you are doing with the worst case time complexity means the value is, here my finding value is 2. My finding value is 2. So when you are going to search for and 2 in a continuous blocks, you will get your best case time complexity, you will get your average case time complexity. So finally the compiler enter into the next block, it's not matching, and it will move on to the last block, it's matching. This is called worst case time complexity. Worst case time complexity will gives you exact result, but it takes time, but the result were efficient. So keep it in your mind, students, this is very useful. So in big O notation we use worst case time complexity, and it gives a efficient result. It gives a efficient result. And most probably in big O notations we are using, compared to the all other notations, most probably we are using big O notation. This is an repeated notation, means repeated notation. Everyone is using this notation. Here in big O notation we need to represent one value. How we can take that value means I will show you. That means here in big O notation we need to take least upper bound value. Least upper bound value. This is an least upper bound value. Now you couldn't understand what is the least upper bound value. Let me give with one example. So first of all I need to take the function for big O notation. Here f of n less than or equal to O dot g of n. This is the function for big O notation. F of n is less than or equal to O dot g of n. So let me draw the graph for big O notation. So here I am going to draw the graph for big O notation. So this is an x-axis. That x-axis carries n. N means here input. N means input. Here y-axis. Y-axis means time. We can take the value time. So here f of n is less than or equal to O dot g of n. Ante f of n, the value is lesser than g of n. So that I am taking here f of n, and I am taking the one more value, that is g of n. So this is the g of n, this is f of n. This is the graphical representation of the big O notation. Now I am going to show you how we can find time complexity by using worst case time complexity in big O notation. So let me take the function once again so that you will come to know. So here I am writing the function. Function is already there, f of n is less than or equal to O dot g of n. So let me take the function is f of n equal to 2n square plus n. f of n equal to 2n square plus n. So let me substitute. Before enter into the substitution part, we need to find g of n. Here you need to remember g of n is always represents in f of n. Here we will have one condition. What is that condition? G of n is always represents in f of n. So here f of n is what is the highest power of the f of n? The highest power for f of n is n square. Suppose f of n equal to 2n cube plus n square plus n. Here what is the highest power? N cube. N cube is means n power 3 is the highest power. So based on that power, we will decide g of n value. What is the highest power? That power will gives the g of n value. So here g of n equal to n square. What is the g of n value? N square. So let me substitute those value into this function. So f of n is already we are having 2n square plus n less than or equal to O dot n square. G of n value is n square, no? So that I have substituted that. So O dot n square. So 2n square plus n less than or equal to, I need to remove O. When you are removing O, you can keep constant C. Instead of O, you can add constant C. So C dot n square. Here C means constant. That is. So I am taking here C equal to 1 and n equal to 1. So C equal to 1, n equal to 1. Let me check whether this condition is satisfies or not. So 1 dot n square less than or equal to 2n square plus n. Let me substitute n value is also 1 square. 2 into 1 square plus 1. Here I am getting the value 3 less than or equal to 1. Is it a true statement or false statement? This is a false statement because 3 is always greater than 1. But here 3 is less than 1. So my condition is false. So let me check with another example. Let me take the value of C equal to 2 and n equal to 2. So C equal to 2, n equal to 2. Let me substitute the value. So 2 into 2 square less than or equal to 2 into 2 square plus 2. Here I am getting the value 10 less than or equal to 8. Is this condition is true? No. This is a false condition. 10 is always greater than by 8. But here 10 is less than 2 towards 8. So that this condition is false. So let me take another value, that is n equal to 3 and C equal to 3. So n equal to 3 and C equal to 3. Through 3n square less than or equal to 2n square plus n. Let me substitute the value of n. So here 3 square less than or equal to 2 into 3 square plus 3. 3 3s are 9. 9 2s are 18. 18 plus 3 less than or equal to 3 3s are 9. 9 3s are 27. So 21 is less than or equal to 27. Is this condition is true or false? This is a true statement. Finally, we are writing one conclusion statement, that is 2n square plus n less than or equal to 3n square is true for all n greater than or equal to 1. So this is a big O notation of using worst case time complexity. And here I need to tell one more thing, that is n equal to 3, C equal to 3, we are taking these values and this is condition is satisfied. Suppose if I am taking C equal to 4, the condition will satisfies. If I am taking c equal to 5, the condition is satisfies. Initially we are taking c equal to 3. So among these three values, which value I need to take? I already written into definition of big O notation. What is that definition? In big O notation, we need to take least upper bound value. So what is the least value? When coming to these three values, compared to these three values, what is the least value here? Here the least value is 3. So finally our statement, our function is 2n square plus n less than or equal to 3n square is true for all n greater than or equal to 1. So this is all about big O notation. I hope this video is helpful to you. Thank you so much for watching this video. Kindly subscribe my channel. If you have any doubts, comment in the comment box. Thank you so much.